So good evening, guys. We are with Mr. Gurpreet Singh, and Mr. Gurpreet Singh is masters from IIT Roorkee. So he'll be providing us today demo class for mathematics, and he'll be taking through linear algebra part. Yes, sir. We can start.
Okay, thank you, sir. Hi, everyone. So I think we can start right now. Hello.
Yes, sir. We can start.
Okay. So we all know that we have engineering math in our gate for everyone, whether it is civil engineering, mechanical, electrical, electronics, any engineering branch. So we have engineering mathematics as a significant part of the gate syllabus. So today I will be discussing mainly about the linear algebra part. So most of the people from engineering background might have heard this word, but most of the people hear this. Hello?
Yes, sir. We
Some,
can hear you.
yeah, some voices are coming. I thought someone is saying something.
No, sir. I think when they join, some voice may come. Like,
Okay, okay.
yes, sir.
So normally we see in whenever we start studying engineering mathematics, either we start by calculus or by matrices. So the thing is, first of all, I want to discuss is the why part. Why we need to study linear algebra or the matrices for engineering mathematics. Of course, our first priority is GATE. In GATE also, our subsection is engineering mathematics. That is our main goal here. Now, for time being, let's pause this part of thinking and let's just explore why we actually require this in our curriculum even. So that is the bigger thing that we need to address first of all. Okay, some voices were coming again. So
Sir, when someone join, then it will
okay,
come like
okay,
some.
I'll
Yeah,
try to
sure.
ignore that.
Yeah, sure.
Thank you very much. Now, the thing is, I'll call it, this is linear algebra. The thing is, for me, most of the people think there is a race between calculus and linear algebra, that which one is most central to science and engineering. I consider linear algebra is most central to the theme because it is related to CS, it is related to civil engineering, even to mechanical, to electrical and electronics, and some other branches like metallurgy and all other gate or any engineering discipline. So that is the most important thing about linear algebra. So the thing is, for civil and mechanical, I will quote some example before we actually start the topic, because this is most important thing. Why we need to understand why we are doing anything we do. So I'll quote one example from most of the most of the famous examples. I'll start by for example from civil engineering. So in civil or mechanical, we famously know, even people from 12th standard, 11th, 12th physics, we know this Hooke's law. We know Hooke's law, some like stresses are proportional to strain. So the thing is, in that, you might have heard in civil and mechanical students, if they are listening to me, they might have heard this thing called stress matrix. And they might have solved some numerical where they denote the diagonal entries by sigma xs, sigma yy, sigma zz, tau xy, tau yz, tau, tau xz, sorry, and tau yz. And I'm not writing these entries because this is a symmetric matrix. Don't worry if you don't know this particular word, what does symmetric mean. We will discuss everything in this particular course of linear algebra. So, and this is not the end for in this civil and mechanical example. After this, those students need to compute principal stresses, and I think this is one of the most important question from in GATE, civil and mechanical. They need to calculate principal stresses on some object or something.
Yes,
So
we can find eigenvalue and
yeah,
of this
eigenvalue.
matrix.
So this is actually related to linear algebra problem.
Yes,
So the thing is, what the point, my point is, you are not learning this subject just for the sake of this engineering mathematics. We are learning because it will help in your in the respective engineering subjects as well. So I can club one example for electrical and electronics people also. Very famously, they have something called control systems. So in control systems, you have some state variable defined by some column vector x1, x2, xn. So you define the state of the system by this, and you write the control system as x dot as f, function of time and the state. So this dot here represents the derivative. So the thing is here also, and this is any general system. So you start your books and courses start by linear systems A times X, where A is some matrix. Don't worry about all this, but I'm just quoting some example again to solve the state of the system. Again, it is again a eigenvalue problem. Similar to the Hooke's law thing, eigenvalue. Here also you need to find the eigenvalues of this matrix A, and then you solve those eigenvalues and you get this example there. Electronics people have more interesting and exotic examples, like in their communication. People who specialize in communication, they have something called coding theory. In coding theory also, they have many codes like linear codes, some Hamming codes, and Hamming codes. All these things work on linear algebra, and they work on very basic things. They are not some high level mathematics. You need to know about rank, eigenvalues, determinants. These three things are central to everything. And it's not just like only these engineering disciplines have. Even the computer science has many applications of linear algebra. In computer science, the most favorite one are when you study graph algorithms. When you study graph algorithms. So let's, for example, have one example for that also. So if I have some, like, people who are from computer science background can very easily understand what point I'm trying to make. So I have some vertices, I have some edges. So let's say this, I make some kind of graph. So I label these vertices as V1, V2, V3, V4, V5, and I can label edges also E1, E2, E3, E4, E5. Now the thing is, the computer doesn't know that how to interpret this typical information, because right now even I randomly just placed 5 points and connected all this. Computer doesn't understand that. So that's what you learn in, you translate this particular information, very complex and abstract information. This is very complex and abstract for computer, but because computers are dumb, so you translate into a matrix. Again, you get for a graph, you get a matrix. So you make a matrix of the graph. I'm not giving you the details right now how to translate, because that is the part of, for computer science students, in engineering mathematics GATE level, there is a subject called discrete mathematics. So we will focus that part where this is actually part of the syllabus, how you translate a graph to a matrix. So you can make a matrix. You can put numbers in this matrix, and then you compute some special numbers. Special numbers, again, I mentioned up here, like you compute the rank, you compute the eigenvalues, you compute the determinant, you compute the trace. There are more numbers related to, and all these numbers signify something important, some very interesting information about this object. Just for example, I will mention one of the information here, like there is a cycle in this graph. So this cycle, there will be a number in this matrix which will tell that there is a cycle. This one cycle is there. So this is very important. That is the main thing that I want to mention here, that why I chose this as example. and why I chose this particular subsection of engineering mathematics syllabus. Though calculus, all of you are very much, I know, you do this calculus part from your 11th, then 12th, and even in GATE also 50% of the syllabus is still from 11th and 12th. So in calculus, and you are already handy with the calculus. You know all these notations of doing d by dx of f of x and doing the integral and some property related to it. But this is the subject which is very ill treated according to me in most of the institutions like colleges, and they don't treat it well. You might have done some courses in your institute by the name of, in your colleges, I mean to say, like math 1 and math 2 and math 3. So in those, there you, some in 1 or 2 you might have done something related to, they even call it matrix algebra. So my main point is, the main misconception that people have is that we are doing matrices. People say that matrices are very difficult. Hello? Someone is saying something? Sir, voice is cracking. Hello? I think it might be someone might have joined, that's why. Can anyone reply on the chat that if someone is saying, you can put on the chat. Hello? Okay, thank you. And everyone can hear me clearly? If someone doesn't, just put anything on
Yes,
the
sir,
chat.
we can hear you. We can
Okay.
hear.
Thank you. So the thing is, okay, I'll make it full screen. Please remember and don't mistake that linear algebra is something more. It is something more than matrices. Matrices are just a part of linear algebra. You will see when we'll have more deeper discussion on this. That is the main thing. The once you understand the principles behind this subject, you you don't need to worry about like this. Of course, matrices and linear algebra are very closely related, but please don't mistake like you are doing just matrices. And I have seen many books also, many authors, and even some very big coaching institutes books. They start their books by just mentioning square matrix is there, rectangular matrix. They just name the matrices, they just give the properties, and they suddenly introduce rank. They then give properties of rank, then they suddenly introduce determinant. It's everything is very intricately connected to each other. It is not just like very discrete, the randomly things are there and you just go one by one, one by one. So the thing is, we need to understand what in linear algebra is there, what is what is there, what kind of objects are there, what leads us what leads us to the matrices. That is the more important thing. You need to focus on this arrow. This is very important. Okay, so this was my motivation to this topic, and just with these, if anyone has any doubt or anything you want to ask from these, you can put in the chat. I'm just waiting. If everyone is clear up till now, I can move forward. Okay. So I'll go forward. Okay, now we'll start by a very simple concept, which I think all of you might have encountered in your life till now. If I think all of you are from, like, are you pursuing your BTECs or are you pass out? Can anyone just message on the chat? Pursuing, okay, maybe third year or something like that. Because I think you might have, yeah. So you might have come to this concept of system of linear equations. And as far as I can remember, I think it comes from 9th standard in your CBSE. If someone is from CBSE background, so it comes from 9th, it comes in 11th, 12th, you do it. Then in your first, second year again. And in, of course, I mentioned in the above examples, in engineering, you see again and again solving linear equations. And solving linear equation translates to this matrix language. We'll see how it translates. And yeah, and also you please tell me if my speed is fast or slow. You can message and I can adjust myself according to that. So very famously, this is the way we start. I'll start by very simple system of 2 cross 2. We say this 2 cross 2. Why we say 2 cross 2? There are two unknowns. Two unknowns, and we denote it by x and y. And we say these are two unknowns, x and y, and there are two linear equations in x and y. That's how we speak this language. You need to focus on this language. For some people, this language may be complex, but you see, there are two unknowns, x and y, and you need to know these x's and these y's, and you need two equations, two relation between them. So for example, I can take a very good example, like I have 2 times x minus y is equals to 0, and I can have another equation as minus x plus 2y is equals to 3. So this is very simple example. You know how to solve this equation. Okay, can anyone quickly give me solution for this? What are x's and y's? If you know, like, if you don't know, no, don't worry about this. But if you can know, that would be very good. What is the value of solution? So what is x and what is y? If someone can tell me what solution means, you need to find a value of x and value of y which satisfy both of these equations. Yeah, x equal to 1 and y is equals to 2. Yes, this is the correct solution. Now the thing is, you might have done, which some people do, you transform this equation as 2x equal to y. You substitute y is here. You substitute y here, then this equation becomes minus x plus 2x is equals to 3. Okay, then you solve this side. Then I think something. Okay, this is 2x and 2 is multiplied here. So this is minus x plus 4x is equals to 3. Then this is 3x is equals to 3 and x is equals to 1. And then you substitute x here. This is 1 and then you get y is equals to 2. Most of the people do this way. And actually this way of solving the system is elimination in disguise. Why I'm saying in disguise is because there is a format or there is a way to do elimination. Of course, here also you did elimination. You in this equation, you substituted y, you eliminated y. You eliminated y, then you solved for y, then you substituted the value of x, you got solved for x, sorry, then you substitute the value of x here, and you got for y. Why I'm saying in this, guys, will come clear just in a minute. Now the thing is, for larger system, so let's say for 3 cross 3, let's say I have x plus y plus z is equals to 1. I have 2x minus y plus 2z is equals to 3. And I can put one equation here also, like x minus 2y plus z is equals to 2. So let's say I have 3 by 3 system. Now here, it becomes a little bit difficult to do the same thing. The same thing, like getting, of course you can do, you can represent, you can get z from these two equations, substitute here, then you can do some juggling here, but it doesn't seem easy as it seemed in 2 cross 2 system. Okay, now the thing is, here what people started doing is they came up with a very systematic approach. That systematic approach is, first they thought, why not translate this system of equation into some handy notation. So they came up with a very intelligent notation. They said, if we collect all the coefficients here, 1, 1, 1, these are the coefficients, 1, 1, and 1 here. Then from the second row, 2, minus 1, and 2. Then 1, minus 2, and 1. And they placed this very long object, I will say, I will not say the name first, x, y, z, and then they made this notation. Don't worry if you don't understand this notation, we'll go through it again. They came up with this notation and they named this very famously as A, and this told this as a capital X and this as a small b. They came up with this AX equal to B system. So definitely I think all of you have seen this equation in your engineering subjects. Have you seen? Can you please reply that? Have you seen this? Yes, AX equal to B equation. I'm not saying you might have noticed I'm not saying this as a, of course they're saying it as a matrix. They're saying this as something very, as a column vector. They say all these heavy, hefty names. This is also column. We'll define each and everything. Don't worry about this. Because this is, for me, even for me, when I was learning this subject, for me, this thing from this to this, it's a big jump. It's not a small jump. It is a big jump. You can't come because if this system, if I call this system as system 1 and this is, because this is system 2, it is in different notation. Now I'm telling you guys that system 1 and system 2 are same. Then I need to show it how it is same. Yeah, can you please reply? Yes. Am I putting a valid question, and can you comprehend the question that I am addressing here? It is very simple thing to, you can say, sir, we know that this system are same, but I'm saying it is not very simple thing. Can you please reply on the chat that, are you getting the point? What I'm trying to make is like system 1, this is represented in 3 equations, and I have come up with this very weird kind of notation of these boxes. Yeah, so the thing is, I need to show you guys that system 1 is equivalent to system 2. If I say that this is the case, what I'm assuming is, if I say that, like I tell you guys, like, yeah, system 1 and system 2 is same, you can go from here to here and you can go from system 2 to system 1. See, from system 2 to system 1, if you need to go, you need to do some kind of calculation here. You need to do some kind of computation here. What that computation is, That computation is called matrix multiplication. Matrix multiplication. If you do matrix multiplication, you multiply this matrix with this something which is not easy. Of course, I will address that just in a minute. If you know this matrix multiplication, then this thing is very trivial. Then this is very trivial. 1 and 2 are same. There is no difference in them. But if you don't know it, and actually that is the thing I want to discuss now. What is this product? What is this operation? Because it's an operation. What is this operation? Matrix multiplication. It is not simple. We will just address that. Okay, so we'll come back to this part. And this is what I want to discuss right now is matrix multiplication. Wait, sorry. And to understand this, we have two approaches. Okay, and one approach, I think you already know it. And for this, I'm again going back to system of linear equations, because from there we got at this point, very weird point of matrix multiplication. We'll go back to this system of linear equation, and I will go to this very trivial example of 2 cross 2 system. I will take this system. This was, I think, minus 2x or 2x minus y equals to 0. 2x minus y is equals to 0. And I think second equation is minus x plus 2y is equals to 3. I will tell you what this is. I want, but before we need to see, we'll start from here. Again, that system of linear equation again, because everything is connected to these two equations. Now, of course, you gave me very quickly the results that x is equals to 1 and y is equals to 2. Okay, so I have one question for all of you guys. Can you give me, how do you view this two equation and this solution geometrically? Can you give any one of you on the chat, can you reply this? How you view this geometrically? Geometrically, I means on x, y, I will start, even I will give you a start on, like, this is x axis, this is y axis, how this is represented here on this plane. Guys, can you reply on the chat? Okay. 1 and 2, no, I'm saying this full, even these two equations also. Even these two equations also, how they look on this xy plane. I think this also you study in your 9th and 10th. Yes, Ivan has replied. Straight lines. Yeah, but straight lines, but this system is very special. Okay, you will get one line for this. 2x, y is equals to 2x. So if I have this one thing, so you will have one line like this. This represents one line. 2x minus y is equals to 0. This one. I'll choose another color for another one. So this will represent another line. Okay. So this line, because this line passes through region, and this line will look, because this also has positive slope, This will look like this. Okay, so my drawing is a little bit bad here, but this x is equals to 1 and y will correspond to 2. So you get this intersection point. I think everyone knows this particular way of viewing system of linear equation on a plane. Each linear line each linear equation corresponds to a line on this xy plane, and then if they intersect to a point, that point is called the solution point. This is this point. Okay, so why I am focusing on this very trivial thing is because we have a name for this approach. We call this as row picture. Just remember this, because whatever terminology I am referring or introducing right now, it will help in solving those questions in future. Okay, so this way of looking, because why I'm telling you all this again, which you already know, because we are putting some names to our approaches. Okay, why? And now I want to explain why this we call it as a row picture. Because you see, I look at the rows. This is one row in this notation. If I translate this system also into my that very awkward kind of notation, right now I'm using the word awkward, as 2x minus y is equals to 0 minus x plus 2y is equals to 3. If I translate it into this notation of 2 minus 1 minus 1 2, again this has x y and this has 0 3. Don't worry if you right now don't know how to translate this into this or this into this back. Give me 5 minutes, you will know how to do this. You will know two ways to do it, not just one way. Okay, so why I'm saying it as a row picture, because you are looking at, you call these across these horizontal lines. If you look at this way, we call it as rows, and if you look at in this way, we call it as columns. This has nothing to do with anything with math thing. This is how English language work. This is how we say rows and columns. So you looked at a row because each row is corresponding to a linear equation. This second row is corresponding to a second equation. And you looked at it, you plotted it on a graph paper or a plane, then you got this intersection point. That's why we call it as a row picture. You looked at the row, you plotted it, and you got the solution. You are lucky to get the solution. There are many possibilities. One possibility is line can be parallel to each other. Okay, or third possibility is the line can be same. Okay, it is coinciding. So you have these three cases. I think you might have encountered this concept also. So here we got a unique solution. We call it as a unique solution. So main thing to focus here is this one way, and this is how you did it. Row picture. Every time you see any linear system of equation, even for can anybody tell what picture we get when we have 3 by 3 system, when we have 3 unknowns and 3 equations? Can anybody tell? We have ax plus by plus cz is equals to, let's say, alpha 1 some number. What does this represent? Please, can you reply on the chat? Like, what does this represent? Ax plus by plus cz is equals to, I can put numbers also, 2x plus y plus 3z is equals to 9. Can you tell? Linear equation, of course, it is a linear equation, but just like here, geometrically I'm asking, this linear equation looks like a line. This looks like a line. Linear equation degree 1 is also correct, but I'm saying what you are giving me the information, the student Sunny, you are telling me algebraically, you are telling me the things. Algebraically, you are telling me it is a linear equation. Of course, linear equation degree, you are telling me it's 1. This is also correct. Both replies answer are correct. I'm asking, this is algebraically. I'm equation wise what you say. I'm asking geometrically what does Ivan is saying represents a plane. Yeah, it represents a plane, but you said which is perpendicular to the vector. Actually, can you tell me like how you came up with this condition perpendicular to the vector? Because I haven't mentioned any extra information here. I've just mentioned the equation. I've not mentioned anything more. Your answer is correct, Ivan Roy, that this represents a plane. If constant remains, yeah, that's why I have not put alpha 1 as 0. I've not put alpha 1 as 0. Your answer is assuming that alpha 1 is 0. Yeah, you can't assume things. Okay, so your reply is correct. This represents a plane. So in 3x3 system, we have 3 equations. Okay, so yeah, I will write them in general. A11x plus A12y plus A13z is equals to B1 A21x plus A22y plus A23z is equals to B2. And then we have third equation A31x plus A32y plus A33z is equals to B3. So each equation represents a plane. So you can call it P1, plane P1. Then we have plane P2. Then we have plane P3. It is just similar to this example, where we have 2x2 system. Each equation corresponds to a line geometrically. See, what I'm trying to build here is, see, one is algebra and one is geometry. Okay, I need to tell you guys this. Okay, we'll constantly jump from one I will call it as the islands. Okay, algebra island and geometry island. Okay, so the thing is, your understanding of the subject, you will have good understanding if you can jump from one island to another very instantly. Just in a split second, you can visualize the system here, and in a split second you can visualize the system here, and this will help you tackling the question very fast. That's why I'm putting more time to this. So what I'm saying is, this, when you do this, these two equations are there, you substitute and all, you are doing all this juggling in this island, algebra island. At the same time, you need to see geometrically what does it do, because right now this is very simple idea. I mentioned it, 9th 10th ideas. Okay, but same thing, same kind of approaches will translate to more complex topics like rank. Okay, rank and determinant. And third one is eigenvalue. These are your most important part of your syllabus. And for these concepts also, I will try to discuss in the similar manner. We'll have understanding in this algebra island also and in the geometry island also. so that we can switch whenever we want. Of course, our answers and the how you see that whether the answer is correct, this algebra part will be more helpful. But to give you more deeper understanding, this geometry part is very beautiful. Okay, so that's why I am focusing more on this. So similarly, coming back to this 3 by 3 system, so because each of these equation are involving three unknowns. Okay, three x, y, z. So this whole equation represents a plane. This represents a plane. This represents a plane. And let's suppose that very good numbers are there. These numbers are very good. X, A11, A12. This AI, we have a shorthand notation for this AIJ, I and J, AIJ. Let's say these numbers are good. Just in the case of 2 by 2 system, these numbers were very good. 2, -1, 2. These were good numbers. That's why we got this unique solution. This unique solution 1 and 2. Similarly, let's suppose, I'm supposing this. I'm not telling this happens always. But let's suppose these numbers are good. What will happen when you get a unique solution? Unique solution means you get a unique value of x, some unique value of x, some unique value of y, some unique value of z. So even we can suppose those unique values. Let's say you get x is equals to 1, y is equals to 2, and z is equals to 3. Let's suppose you solve this system, some method I tell you, and some method, you believe me for time being, some method is there, and that method gives x equals to 1, y is equal to 2, z is equals to 3. What that method lives in Algebra Island. Okay, for future times also, please call it as Algebra Island. Okay, so in this Algebra Island, some mechanism, some method, some magic trick, something is there that gives us this, that x equals to 2, y is equal to 2, z equal to 3. Now, my question is, what I want to tell you is, what does it represent in this island? What happens in geometrically? What does it say? So geometrically, if anyone wants to try, can you if anyone wants to try to answer this question, of course I will answer. If anyone wants to try to answer this question, you can try it. You can reply on the chat, because to me it seems an interesting question. Guys, you can reply on the chat. If you don't know, you can also write, you can write don't know. There's no problem with that. Okay, don't know. Kajal is saying don't know, no problem. My question is, did you got the question what I'm saying, or you don't know the answer? At least you are getting the point. You're getting what I want you guys to tell. Okay, good. Kajal, you got the question. Okay, that's a good news that you got the question. Okay, anyone else want to try to answer what I'm saying? What question I'm asking you guys? Okay, I will try to answer. Okay, so the thing is, we had 3 equations, and I'm telling you that some mechanism is there. Don't worry about that mechanism or method, that how you solve that method. I'll solve those, and you get this unique solution as x equal to 1, y is equal to 2, z equal to 3. And by till now I have told you that each equation represents a plane in xyz. In xyz, what happens when I say xyz? xyz, if I try to draw, okay, let's try to draw with the straight line. Okay, so I have this straight line. Oh, sorry, I need to choose one straight line again. So this, till now I have x and y. So this represents a plane. Okay, now we have a third variable. So of course, our screen is 2-dimensional, so it's difficult to visualize, but try to. So we call this as x, this as y, this as z. So this is we call it as 3-dimensional space, okay, in which we all live and we are actually attending this lecture. So this is our XYZ three-dimensional space. So here, first equation, this, or we can have this equation also, 2x plus y plus 3z is equals to 9. Of course, right hand side is 9 and it is not 0. If it is 0, then just like this equation, 2x minus y equal to 0, because right hand side is not there, it passes through region. These are some basic facts from geometry which are, I think, you might have covered in your 11th, 12th, 9th, 10th, from 9th, 10th, 11th, 12th. These are simple facts from if right hand side is 0, that line passes through region. Similarly, if right hand side in 3 variable equation is 0, then that plane passes through region. So let's say these are not passing through regions. So one of the, I'll try to draw using one color. Let's say we choose this one. So that represents one plane. Okay, I'll call it as plane P1. So first equation corresponds to one plane in this three-dimensional space. Similarly, I draw another plane. This is behind that plane. That's why I'm marking as dotted. So this is another plane. So they are intersecting. So can anyone tell me that if two planes intersect, how two planes intersect? Like what kind of object, what geometrical figure you get when two planes intersect? Can you please answer? See, in the previous example, when two lines intersect, so you get a point. When two planes intersect, what do you get? Guys, you can answer on the time. You get a line of intersection. That's very precise. Yes, you get a line of intersection. So when two planes intersect, you get, let's say you get this, I represent by black, you get this line of intersection. Somehow, of course, this image will be very difficult to digest because of my drawing, but you get one line of intersection. Okay, you see with this intersection of plane P1 and P2 gave you line of intersection. Okay, then you have, of course, now this will be very difficult to draw here, but I'll try to draw some horizontal kind of plane here. This is all behind. Okay, and this comes out, and this is the third plane. Let's say third equation corresponds to this third plane. Okay, so now P1 intersects with, see how many intersections we have. We'll note down everything is happening because here a lot of things are happening. See, P1 is intersecting with, so P1 intersects P2. Okay, P1 intersects with P2, you get one line. Okay, then you can also tell that P1 intersects with P3 also, because P1 is yellow colored and this intersects P3 also. You can represent that by this color. Let's say that intersection of P1 and P3 is like this kind of thing, this kind of line. Okay, so you get this line, you get this, I'll call it as line, we'll name it as line alpha. Okay, so by intersection of P1 and P3 you get line alpha, and by intersection of P1 and P2 you get line, this line, let's call it as line beta. You get line beta. So of course these two lines are also intersecting. That's why this is the point of intersection of these two lines, and that's why you got the unique solution. So whatever that magical method I told you from algebra island you have, So geometrically, this is that point. X equals to 1, Y is equals to 2, Z is equals to 3. This is one way of looking at it. You can look at it in a different way, like P3 intersect with P2, P3 intersect with P1, then you get two lines. Again, those two lines intersect, and then you get this. Again, you will get whatever way you look at it, you will get this point of intersection. So these three planes are intersecting, and then you are getting a unique solution. Please, I just want a confirmation and feedback from you guys. Like, did you got this? You understood this? Can you guys reply that? If anyone has a doubt in this, whatever I have discussed. Okay, you got Khushbu has replied that she understood it. Okay, they understood. I will assume one more guy can reply so that I can take it as like you guys understood it. Okay. Yes, Ivan has replied. Good. Okay. So again, still, this is again, we are on the row picture. Again, I will mention it. This is again a row picture. Remember it. This is a row picture because you are given some system of equations. We call it as 3 by 3. Why 3 by 3? Because you have 3 unknowns and 3 equations. This means 3 unknowns and 3 equations. Okay, that's why we call it as 3 by 3 system. So, and this way of writing the equations and talking in the terms of equations, and what the way Ivan was replying the degree and all, this is from this. Remember this. I will try to tell in this terminology. This was all from algebra thing. We are trying to look at it geometrically. Look at it like geometrically. So each equation correspond to plane, and this is the picture. This is not good. You can Google this. You just write 3 by 3 system geometrically. You will get the pictures. And if I make some notes for this lecture, I'll put that picture there. Don't worry about it. But if you make it using computer graphics, you get a better picture. My drawing is not good here. So we'll move on to the second thing. We have spent enough time here. Now, second thing is very powerful. That's why I have introduced it. Introduced after the row picture. That powerful thing is column picture. And this, please guys, I'm telling you, this will help you crack questions very easily. And this will help you understand full subject of linear algebra. Like, this is like kind of a hack. I will write small in small letters, like it's kind of a hack kind of thing. I didn't know when I went to college, I got to know this approach. And I will also ask you guys, have you seen this way of looking at it? So we'll again, for column picture also, we'll go to 2 by 2 system. And I will also mention the book or person from whom I learned it. It is from Professor Gilbert Strang. So it is book by Professor Gilbert Strang, book Linear Algebra. From there I learned it. I'll share it with you guys. I'm mentioning the source also if you want to explain yourself. So again, we'll start from 2 by 2 because similarly, the way we looked at 2 by 2 row picture, similarly, we'll go to column picture also from 2 by 2. So, and remember one remark I want to make is, see, from here in 2 by 2, we could also solve the system and look at geometrically. And whatever approach we followed here, substituting, finding y in terms of x and substituting here, we kind of found difficult to do it here because here we have more numbers, more equations. It becomes little, of course, still doable. It will take you a little bit of time. I think 5 to 10 minutes. If I give you all these numbers and these numbers, it might take you 5 to 10 minutes. Similar approach, you calculate, for using these two equations, you eliminate x. Using these two equations also eliminate x. Then you get two equations in terms of y and z. You solve those equations like here. Then substitute that y and z here, you get x. So this is roughly the approach, but still you see you need to do a lot of computation. And we looked at geometrically that this is what it represents. Now coming again, I will take the same example because that is very good example. 2x minus y equal to 0. 2x minus y is equals to 0, and I think second equation is minus x plus 2y is equals to 3. Okay. Now, how I want to look at is, see, I mentioned columns. Column picture means, again, I will write this notation here again. 2, minus 1, 2, x, y, and this is 0 and 3. First, we looked at row wise. This we are done. Now we want to look at it this system by columns. Now how to look? See, if I see only the column 2 and minus 1, this was the first column. See, this is the first column. I put x here plus, then second column is minus 1 and 2. This is y here, and this is equals to 0 and 3. I have translated this system of equations into this. I put everything. This is same. And I think from here, if I call this as system 1, okay, 1 I have used again, system A, this is system B. I think from B to A, you can go very easily. B to A. Please, can you reply that? Can you go from B to A? B means from here to here. Can you reply on the chat? Aneep, yeah, you just multiply this. Now you multiply. I will do it. Still, I will do it. I will erase because still I will do it. Like this is multiply inside. You do it. You get this. Then you do minus y, then 2y, and then 0, 3. Then what you do is you add these two, because what is this? I think you know this. I think I can say the name of this object. Like this is a vector. I think everyone knows vector. This is vector. You know vector addition, and you know how two vectors are equal. So this is vector. This is also a vector, and this is also a vector. This is also a vector. So you add two vectors, then you equate the two vectors, and you get these two equations. It's easy. Okay. So I'll erase this thing. From B to A, it is very easy. Now, something good happens when you look in this way. Now, what does it say? This is very important. I will write in very big letters. What does it say? What does it say? This is a vector. This is a vector. This is also a vector. This is also a vector. This is vector, vector, vector. What does this equation is trying to say? Of course, this plus is there. Anyone wants to try? Like, can you just see? Don't worry about like whether the answer is correct or not, right or wrong. Just try. Just look at it. I have mentioned everything here. This is unknown. X and Y are numbers. X is a number, Y is a number. This is a vector. This is a vector. This is a vector. What this equation B is trying to say? Someone wants to give it a try, because that's how you will learn. Try to guess, try to see like what does it trying to say. Please guys, can you this is my request, because that's how That's what mathematics requires. My question is, what does this equation is trying to say? Hello? I am not getting any reply from anyone. Is it seeming difficult to you? Okay, I'll make a little bit more easy. Like, can you tell? Okay, I'll break down this question in parts. Okay, I'll make it into parts. Tell me what happens when you multiply a vector by a number. Can you tell me? At least answer this part, just this part. I will break the question, then we'll collect the answers, and then we'll answer this big question. Some vector is there, some vector is there, and you multiply it by a number. Even I will give you an example. Some vector, I'll take this as a vector 2, 2, 1. This is one notation you can represent like this. Also, you can represent like 2i cap plus j cap. These are all notations, don't worry about. So I have this vector. I will also name this as a vector v1. So all these are different notations. So what if I multiply it by 2? What does 2v1 represents? Can you reply? Can you give me answer for this? What does 2v1 gives? 2v, no, it doesn't give magnitude. I'm saying I'm multiplying a number with a vector 2v1. Try to do whatever notation you are comfortable with. If you are comfortable with this, you try to multiply 2 with it. Direction remains the same, magnitude changes. Okay, you can also reply what does it becomes. This is correct. 4, 2. Yes, good. So it becomes 4, 2. So if you see, even I will draw small picture here. So this is 1, this is 2, 3, 4, 1, this is 1 and 2. So this is 2, 1. So this was v1. Okay, then you did 2 times v1, so it becomes 4, 2. So I'll change the color. So it became this 4, 2. Okay, so what happened? Can you give this change? Whatever change happened, this change has a name. Can I call it as stretching? I think it got stretched. Stretching happened, or you can say it elongated. Geometrically, it happened this way. It got the v1 got elongated. It got stretched. Okay. And my second question is, what happens when you add two vectors? This, I think this is two vectors. This is very trivial. I think all of you know this. You have this vector v1, you have this vector v2. Okay, I'll go very from the beginning. Let's say v1 is here. Then all of you remember, yes, you get third vector. You bring this vector v2, you bring the tail of this vector to the head of this. I think all of you are maybe feeling nostalgic by listening to this. So then you add these two vectors, you get a third vector, v3. Okay. a resultant vector. Yes. So if you look closely to the equation B, see here, this is one vector. It is getting multiplied with this. This is another vector getting multiplied with this. Okay, this is happening. A lot of things are happening on the left hand side. Right hand side is very boring. It's just sitting there. It is just a spectator. Nothing is happening on the right hand side. I can write this equation again for you guys to understand. What is the first vector? I think it is 2 minus 1. It is 2 minus 1 times x plus, I think this one is minus 1, 2. Minus 1 and 2. I'm just writing the left hand side because if you understand left hand side, right hand side is nothing. Now are you able to see the left hand side what's happening? You don't know right now the value of x and y, but if somehow x is there, y is there, x is stretching this vector. This vector. We can name this as vector v1. You can call it as vector v2. And this becomes v1 times x plus v2 times y. Okay. So, and we call the right hand side, that is another vector 0, 3, and we call it as vector v3. So this is v3. And even if you like these bars on your vectors, I can put bars also to differentiate from it from the scalars, because x and y are scalar. I have translated the equation b into something like this. This was equal. Now, when I have now we have broken down this big question into two parts and we have worked out. Now I want to give you the chance to explain what is happening here. What is happening like here or here? Can you want to try? At least I want you, because for me all this is like a movie. Like I don't want to give you spoilers, just everything I am telling you guys. At least give it a try. Now can you give what is happening? What does this equation say? What does this system B says? Please try to understand. Please try to give anything, whatever comes to your mind. We have discussed, we have broken down into two parts. Very good. Yeah, Kajal, you have replied perfectly. The vectors are getting elongated, or sometimes, yes, I want to make one correction. If you multiply with negative numbers, it will reverse the direction also. Okay. So stretching and some elongation can happen in another way also, but then you are adding and it is giving another vector. So let's say you do some stretching with this number x, you do some stretching with this number y, then you get some vector. That vector should be equal to this v3 vector, because remember v3 vector is fixed, it is already there. Okay, and you guys don't worry, I will draw a picture for this again. For this also we'll draw a picture, then you will definitely understand very nicely. So we have this y-axis and we have this x-axis. Okay, so this is x, this is y. Okay, okay, so yeah, so we'll see what is this vector v1. This vector v1 is 1, 2, 3, 4, 5. So this is origin. I will spend 0. So this is 2. We'll do a little bit farther. So this is the vector v1, which is 2, minus 1. Okay, this is vector v1. How does v2 looks? -1, -2, -3, -4. This is -1 and this is 1 and 2. So this is, I will choose another color for this. This is this is your V2 vector. Okay. We have another vector. We have V3 as well. So we'll put that in this color. How does V3 looks like? V3 is 0 and 3. So this looks like this is V3. Okay. We have V1 here, V2 here, V3 here. Geometrically, they look like this. Okay. Now, system B is saying we need to find these unknown X and Y. What are X and Y? How to elongate V1 and V2 or stretch or change the direction anyway, whatever juggling we need to do, so that when we add these two, we need these number X and Y need to be very precise in that way that when the vector addition happens, it becomes equal to V3. Okay, did you got what I'm saying? I will do it on the graph, but yes, good. Just follow me. I will tell you when I complete it. And you already know from the row picture. From the row picture, we know that you need X to be 1 and you need Y to be 2. 2 means Y2 means you need to double your this vector. You need to double your this vector. So I will choose this green color. So again, so this becomes your roughly this becomes your 2v2. Then you add it to, this is your 2v2. Then you add it to your v1 because x is 1. So how you add? You translate it here. You put the tail of this to the head of this. And then when you add, this will look like this. So when you add this vector v1 with this vector 2v2, this equals to this v3, that is the right hand side because that is 0, 3. So these two numbers 2 and 1, x is equals to 1, y is equals to 2. This is another way of looking at geometrically another way of looking at. Please tell me. I find it very, like, I get goosebumps when I learned this. I got goosebumps. I really am telling you my honest experience. Did you look there? Please tell me, have you ever looked the system of equation through in this manner? Can you reply yes or no? And Kajal has replied no. And my next question is, have you understood this? Have you understood, like, what does this? I have named this thing as column picture. And I'm telling you, and actually, if people are very religious toward the row picture, they're very religious. I have met people who are fanatic about row picture, but with row picture, you see here computationally also it was becoming difficult. Even geometrically also this is becoming difficult to even draw. Now see the beauty of the column picture. I'll draw again. Oh, doesn't matter if it takes a little bit of time. See, this is y-axis, then this is x-axis, and this is z-axis. Oh, sorry, I'll do the undo here. See, if I have 3 by 3 system, if I have 3 by 3 system, what will happen? I will have some numbers, let's say 1, 2, 3 times x plus 4, 5, 6 times y plus 7, 8, 9 times z is equals to some number, let's say 0, 0, 1. Let's see. This is the system of equation. You can see very easily, you can see right now. See how powerful this picture is. This you can call it as vector v1, this you can call as vector v2, this as vector v3, and this as vector v4. And what this equation is saying, you need to elongate or stretch or convert or make it into like invert, because if -1 is there, this vector changes the direction. Okay, you need to stretch it. In general, we will call stretching. Okay, but don't fix your idea stretching to words like if some vector is there and it will only happen in this way. Of course, it can change the direction also. Just keep in mind, you need to do all this, then you need to add these vectors so that you get this vector v4. So you can very easily, of course, due to because our I can choose one color. This can be vector v1. Okay, from origin, this can be vector v2. This can be vector in this direction v3. Okay, then what do you need? You need nothing. You just need to find how to elongate or stretch or do these 3 vectors. Then we do vector addition so that we get what vector 0, 0, 1. Where is 0, 0, 1? 0, 0, 1 is this vector. See, I'll choose another color for this. This vector. This vector is v4. Okay. See, at least little bit I consider from this picture, this is more cleaner and more powerful. And with further we move to understand more concept like rank and other things, you will find column picture is helping everywhere. Okay, so this how and now after discussing this, I will come back to why I started all this discussion is this thing, this giant. I consider this as a giant matrix multiplication. Okay, so let's finish that matrix multiplication thing. Okay, just keep both of these concepts in your mind, matrix multiplication. And I will tell you the conventional, or I also call it ancient. This is kind of a joke to the system, ancient way. Okay, so let's say I have this matrix 1, 2, 3, and 4, and I have this vector 1, 2. So I think how you learn in matrix multiplication, even I think it comes in your 12th standard or 11th, 12th. They say multiply this by this, then this by this. Okay, and multiply this by this. I'll write each of the steps 1.1, then this by this, 2.2, then add plus. Then they say do this number by this 3.1, then this number by this 4.2, then add. Then you get your solution. 1 plus 4, 5, and 3 plus, I think 4 to 8, 11, I think. Correct me if my calculation are wrong. I do these kind of mistakes, but please reply. I think this is the way you learned matrix multiplication. Yes. Now you see, and this way of multiple is connected to the row picture kind of a thing. Not approximately, not exactly approximate. I'm using this. Exactly, if you want to know how this is happening, this way of multiplying is actually dot product way of multiplying. We'll come back to this, but this is how your school teachers also taught you how to multiply the matrices. And still it is not matrix. This is a vector. This is a vector and this is a matrix. See how much calculation you need to do if I have a matrix here, some matrix A and some matrix B, 2 cross 2 and 2 cross 2. Even 2 cross 2 matrix multiplication using this approach will take a lot of calculations. Now I will use column way or column picture. Okay, what was the matrix? 1, 1, 2, 3, 4, and this was 1, 2. I think you should be, by this far, you should be able to understand. See, this system looks like just this system looks like this system 1, 2, 3, 4. And this, if let's for time being, these are, you don't know these x and this, let call it x and this as y. You can see this is how your system looked. This here, these two equations were looking like this. Can you see? These were the linear equation, then we made into matrix, then I came to this, and I told you from B to A you can go. Okay, so how you converted this? Column picture was, you write one column 1, 3 and multiply with x, 2, 4 with y. This is saying you multiply x with first column, this column, multiply y with this column. See, this is what you did here, translating this to this and even back. So if you follow this approach, what does it say? You multiply 1 with this column, 1 with 1, 3, and 2 with this column, and add 2 with this column, second column. See, this becomes more. In 2 by 2, you might not be able to see the handiness of this system with 3 by 3, 4 by 4, even higher order matrices. Of course, in GATE, they have seen question till 4 by 4 and 5 by 5, but still, there it will be very helpful. So this gives you very nicely. This gives you 1, 3. This gives you 4 and 8. And this becomes 5 and 11. Please, do you also feel? I feel, of course, this way of multiplying and looking at multiplying matrices with vectors and even matrices with matrix is better or even easier. Can you guys tell me how you are feeling with this? Please remember this way. Okay, so if 3 by 3 matrix is there, I will write, okay, 1, 2, 3, minus 1, 0, 2, and let's say we write 4, 5, 9, and we have this. Let's say we need to multiply 1, 14, and 8. If you go by that approach, this takes, of course, this will also take calculation wise. I think there is not much difference, but it is more neat and more powerful. What does it say? It says 1 times the first column, then 14 times the second column, and 8 times the third column. This is equals to this. You multiply columns, then you find at the last the column. Please guys, write for till now. I just can you? I will scroll back, and if you have any doubt, please tell your doubts. For 4-5, I'm giving you 4-5 minutes. If you have any doubt, I will go back to that section and I'll explain again. And you have calculators in your hand, or if your calculations are okay, I'll make easy for you. Okay. Make it as a 4. So make it as 4. Okay, I'm seeing some numbers 53, 15. Okay, you are giving, okay, you gave me that full vector with 14. Okay, good, Kajal. With 14, this comes as something like this. And rest of people, if you have not solved it, you can, by taking 148, you can give me. And if you have any doubt anywhere, I will slowly scroll. Okay, no problem, Kajal. Okay, good. I can scroll slowly. I'll scroll up and down. Anywhere, if you have any doubt, I can explain again. And rest of the people, please try to solve with 148. Let's go back to the question. Okay, Angel, sir, at the column picture in the graph, can you explain how V3 resultant vector is drawn? Okay. In 3 by 3 system, are you asking, or in 2 by 2 system? 2 by 2 system. Okay, this is 2 by 2 system. See, it was 0, 3. Okay, it was 0, 3. So 0 x coordinate is 0, and this is 1, 2, and 3. So I took it as 0, 3. Our alternate notation is like this horizontal way, or another way is 0 I cap plus 3 j cap. So this vector is here on the y, because x coordinate is 0, so that vector is this parallel, these are on the y axis. That's why this is v3. Okay. Okay. So have you guys did this multiplication and added the vectors? Can anyone give me? I will write it down. Of course. Give me these 3 values. First value will be 1, 4 to 8, and I think 8, 3, 24. So first coordinate is 1 plus 8 plus 24. Second coordinate is -1 plus 0 plus it is 16. And this is 4 plus 20 plus 72. Now you just need to add the 25 plus it 33. This is 33, this is 15, and this is 24 and 6. Okay. Good. So now we'll move forward. Okay. I hope all of you understood whatever I'm trying to make this, and I will refer back to this terminology again and again, and it will help us. Definitely, it will help us. Okay. I'll again and again I need to write this system of equations. So let's say we have this 3 by 3 system or 2 by 2 system. Okay, 3 by 3, we know how we wrote it. We have this a1 a11 x plus a12 y plus a13 z is equals to sum b1 a21 x plus a22 y plus a23 z is equals to b2 a331 x plus a32 y plus a33 z is equals to b3. Okay, now I have this. Now I don't think you guys will have problem in if I write in this notation a11 a21 a31 a12 a22 a32 a13 a23 a33 times x y z is equals to this vector b1 b2 b3. Okay, now if I say translate back to this system, do it using column picture. Okay, I will write it down here for you guys. So column picture says x times first column a11 a21 a31, then y times this a12 a22 a32, and third is z times a third column a13 a23 a33 is equals to this vector b1 b2 and b3. Okay, using this, then you multiply, you get these three equations again. This is just repetition of what we did above. Now I want to tell you guys, we have something, we call this thing on the left hand side. You guys yourself understood very clearly that you are doing some stretching and then adding, or you're doing this. You're doing two things here. You're doing stretch plus addition. Okay, you're doing two actions. I'll call it as actions. Okay, this, and remember, I will tell you first, then I will explain. This is called linear combination, but I need to call them, I will call this as vector v1, I will call this as vector v2, and I'll call this as vector v3. Okay, so this is called as linear combination of v1, v2, and v3. Why it is, you need to understand this word linear, this thing. Why we are calling it as linear? This is very important. Because you are not doing, you're doing x raised to 1, y raised to 1, z raised to, you are not doing x square times vector v1. You are not doing x square times v1 or some y cube v2 or z, let's say I'll keep z like this. You're not doing this. You are scaling it just by one number. You're not scaling it by some another function. You are not doing this sine x times v1. You're not doing something very exotic like this. Are you getting my point? Of course, linear combination, this word is coming from Algebra Island. Algebra Island. Okay, this action or this definition. This definition is algebraic in nature. I will tell you when the right time comes what geometrically this means. Linear combination of v1, v2, v3. Right now you need to understand that we are not doing some crazy powers of x, these unknowns, and then taking computation. Okay, we are doing just x times the vector v1, y times the vector v2, z times the vector v3. And one possible explanation you can have from vector addition. Because in vector addition, you do this v1, v2, you add these two vectors, you get third vector. And you have this picture of this v1 and this some vector v2 is there. You translate it. While translating, you don't change the magnitude and direction, because when you don't change, you just bring the tail of the v2 to the head of the v1 and you get this v2 and then you add it. You do this and what else is required? You do second thing is scaling. That stretching, the better word that I was looking is scaling, because in scaling if you multiply v1 with -1, then this happens. So in scaling, this is included. So you do scaling. Scaling is done by multiplying a number. You multiply some constant c with a vector. Let's say some vector v, you multiply. So because the nature of these two operations, we say that we do linear combination. Sorry for the noise. I think you might be getting noise some. Okay. So there is not just I'm defining it and I'm mentioning the cases what it is not. Okay, this is not this. So I can write the full metric system, this full matrix A11, A12, A13, A21, A22, A23, A31, A32, A33, this times X, Y, Z is equals to, again I'm writing, because you also try to when you revise this, try to write all these systems again and try to speak how you are translating, and you are translating it to column picture. X times I'll write column vector 1 time, y times column vector 2, then z times column vector 3 is equals to this column vector, right hand side column vector b1, b2, b3. Okay, and this is a vectors. Okay, this we call it as linear combination. This is a very important concept. Linear combination of column vectors. Please, if you have any doubt, right, you understood this, please reply. Can you reply on the chat? You understood this. Did you got what I'm saying? This is just a linear I'm telling it as a linear combination. Okay, thank you. Okay, and you also remember, if you remember, I will use another color. We call this as matrix A, we call this as column vector X, and we call this as a vector B. And I think if you attended your first year with somewhat of some seriousness, then you have encountered this system ax equals to b. Okay, so the problem you learn to solve is solve this system. Solve this system ax equal to b. Before even and I definitely confidently I can say you all might have solved also. You have learned some way. One way you might have learned in your 12th standard. Again, I will 12th standard or your first year math. You might have very one approach is you learn this thing that multiply by inverse like you call a inverse. So you multiply a inverse by ax is equals to a inverse b. So you call this as I identity x is equals to a inverse b, and you tell x is equals to a inverse b. You do this. I hope all of you might have encountered this. But still there is one condition that a inverse must exist. A inverse must exist. You need to check first. So your process to solve this system becomes you first check. If I roughly mention that process is check A inverse exist. This is your first step. Check for A inverse exist. Then to check A inverse exist, what do you do? Can you reply like to check A inverse exist or not? What do? You compute something. Can you tell on the chat? What do you compute to compute the A inverse? Don't worry if rest of the class if you don't know these, I will tell all these inverses and all. I'm just trying to put question you because you all this topic you have encountered before. So to check A inverse, how you calculate in A inverse? You compute something. You compute some value which tells you whether A inverse exists or not. If you don't know, you can reply don't know. Yes, you compute determinant. You compute determinant and you represent by det of A. Okay, then you make a decision. Then you make a decision that whether the determinant is equal to 0 or is not equal to 0. If it is equal to 0, you say A inverse doesn't exist. A inverse doesn't exist, and then you say that system is not solvable. You say ax equal to b is not solvable. Okay, is not solvable. This is I'm telling you, this is very old concept. Okay, if it is not equal to 0, A inverse doesn't exist. This okay, then if it is not equal to 0, then you know that A inverse exists. Till this point, you just know it exists. You don't know what A inverse is. Then you need to do this is your okay. Then you come back to the next. Then second step is compute A inverse. Then you compute A inverse. To compute A inverse, I'm not give full because that is very. I don't like that. I consider that process equivalent to this row picture. Complicated. We'll learn another way to decide whether ax equal to b we can solve or not, and if we can solve other ways also. Okay, then compute A inverse. Then you have this very funny or very daunting expression. A inverse is 1 by determinant of A into adjoint, you call it as A at B adjoint of A, and adjoint of A I mentioned again. This is all refreshing your memory. Adjoint of A is actually minus 1 power I plus j. If you don't remember, don't worry. Into one matrix which we call it as minor matrix. Okay, Don't worry if you don't know. Don't worry. I will tell again. Something funny happens. I'll do like this. Some heat is coming. Something hot is there. I don't know. Yeah, transpose of cofactors. The Khushbu has replied. Something is there. But what point I want to make is there are a lot of even in this step. I'll use red color to give to stress on this. It might hurt your eyes, but lot of computation here. Lot of computation here. Even to compute determinant also. 2 by 2 you can do, but 3 by 3, 4 by 4. If I give you 4 by 4 system, it becomes difficult to even compute determinant. It involves a lot of calculation. That is first step. Only if it becomes zero, then your life is little bit easy. That you can say inverse doesn't exist. Ax equal to b, we cannot solve. Then if it is not equal to 0, then more calculations, more computations. Because then you need to compute this entity adjoint, where Khushbu has mentioned transpose of a cofactor matrix. So a cofactor matrix is actually this is cofactors. This is how you compute cofactor, minors into -1 power I plus j. So this again very computationally heavy. Just to see whether we can solve it, and if we can solve it, what is the solution? And I'm telling you guys, using column picture, we can answer this question without this much of computation. Without this much of computation, I mean without computing determinant. Without computing determinant, you can still answer that whether you can solve Ax equal to b or not. So I'll write in green because this is something good news. I'm not telling you how right now, but we can tell whether Ax equals to b is solvable or not. I'll write in capital without computing determinant. Without computing determinant. So I think it's 10:50. Should we end the class? Of course, it is kind of a cliffhanger for all of you. Guys, if you have any doubt, you can tell me, because I was told I need to take till 11, but still we have 10 minutes, but better we can have the doubt kind of a session for 10 minutes, 5 or 10 minutes. Or if you have any kind of questions relating to engineering math, because this is the kind of a first class, or we can have that kind of discussion also. I can continue, I can tell you, but that opens up a new topic. Guys, you can reply on the chat, and even if you can speak on the mic, you can do that also. No doubt, Ivan. Really, because there are two possibilities when this happens. Either everything went over your head, or either you really understood everything. So is it the second case? Because that will be very good news. Okay, thank you very much. But Others also we can tell me, or I can start in. I will try to do in 5 to 10 minutes. I can. Okay, thank you. No doubt. Okay.
Yes, sir, no doubt.
Okay. Okay, so I will start how I will start this. What we'll see in whether 6-7 minutes I can do. Yeah, because it opens up. I'll tell you the answer to this. Yes, I'm telling you, but this I think today I can't I will not be able to completely answer this question, but I will tell you that this answer to this answer to above question, I'll say answer to above statement brings us to look at, now this is, if I had some music with me, I would have done a drum roll, rank. So I think this is the first thing whenever if you would have looked some kind of books for engineering, GATE, engineering mathematics, first thing you learn is to compute rank. Same story goes for rank also. Similar to this inverse and determinant, some method, some method which requires computing determinants using computing determinants of submatrices. So this is the method. Just wait. Computing determinants of submatrices. I'll again highlight this, that this method requires again lot of computation. And most of the books have mentioned this method. Roughly I will tell you. I will tell you in detail also. Let's say some 3 by 3 matrices given 1 2 3 minus 1 0 0 or 4 2 6. So what they will tell you to do is compute the determinant of this submatrix, then compute determinant of this submatrix, then compute determinant of this submatrix, then this, then you have four 2 by 2 matrices. Okay, then you have one 3 by 3, this full 3 by 3, one 3 by 3 matrix. Okay, you get the 4. Okay, you compute determinant of, okay, determinant of this submatrix, determinant of this, determinant of this, determinant of this. You get these 5 numbers. Based on these 5 numbers, you tell what is the rank. Okay, see, and if you guys remember, do you remember this kind of algorithm, this kind of method? Any one of you? You might have seen this kind of. They also they give this funny notation, row 1 1, row 1 2 kind of thing, row 2 2, row 2 3, something like this. They compute these numbers and check whether this determinant of this submatrix is 0 or not, this determinant of this matrix is 0 or not. From there they make at the end they tell you that what is the rank. Do you have any one of you has seen this way of computing rank? Can you reply yes or no? Yeah. Dundappa. Am I saying your name correct? Kajali saying we have done in some other way. Can you little bit explain what other way? Other way is Can you just tell me something? You can tell the keywords. I'll fill the rest for you. Kajal is saying that they have done in other way. Yes, that method is also there. Reduced matrix. That is still better than this. Yes, where you have this matrix 3 by 3 or any order matrix. Let's say some matrix, same matrix I'll write is 1, 2, 3, minus 1, 0, 0, 4, 2, 6, and you reduce it. If people don't know, I will tell you this. What does this reduce the matrix means? This comes in under the topic of this computing or rank. So this is still better. This is better, but I have one way which is, I consider it as the best, because as far as I have seen the questions in GATE, previous year GATE mathematics question, they don't give that much computationally heavy matrices so that you need to row reduce it and then you get the rank. Sometimes I mentioned, please focus on my word sometimes. I will put sometimes here also. Sometimes this best method works sometimes. This is always, and don't go for this method. I tell you don't, because this, you are computing so many numbers, you can make so many mistakes. So there is high chance of mistake here. There are chance of mistake here as well, but this is mistake free method. I will discuss this. This is mistake free, and this is if you get really handy with matrices, if you get really handy with the principle involved. Using this method, you can tell the rank by just looking at it. That is the thing which I will tell you using this new way of looking at the matrices, this column picture. Yeah, Dundappa, yes, this thing is involved with this method. So I think this we will continue further. I think time is up. So definitely from next class, if we have, I'll tell you about how we'll start from rank and how we compute it, and then we'll do some examples also. So you guys, it's 11 o'clock and you can tell me if you have any doubt and if you want to give any feedback about the speed, about anything. Even my handwriting is a little bit bad. And any feedback, anything, if you want to tell. And I think I will make a PDF of this notebook and I will share it with the sir. And I'll try to make some notes and I will try to refer some PDF also for this discussion we had. Or I can share my own notes also. Anyone, please. I'll give you 1 or 2 minutes. Just, and from further, if we have any further class. Thank you. Never knew the column method. Yes. And you will see in rank this, again, somehow unconsciously I have got this habit of leaving you on cliffhangers. I'll maybe picked up from Netflix or Amazon Prime something. This is kind of a question mark or a cliffhanger. I'll put a cliffhanger here. So we can continue further. Okay, Kajal is saying she guessed that she has done this by looking at it. That's very good. Very good. Understood. Thank you. Thank you. Okay, so I think that winds up this lecture, and hope I see you guys again and we can continue from here. Thank you very much. Thank you.
Thank you, sir. Good night.
Thank you. Good night.